For our final set of notes, we want to talk about Graham's law. Graham's law talks about diffusion, which is the random scattering of gas molecules. Gas molecules are forever diffusing through and amongst and around each other. Gases do not diffuse at the same rate. And this is the important part. Molecules of a small mass diffuse faster than molecules of a large mass. So if two substances have the same temperature, and this is where that definition of temperature keeps coming back, temperature is a measure of average kinetic energy. So if they're at the same temperature, they have the same kinetic energy. The kinetic energy of substance 1 is equal to the kinetic energy of substance 2, and we're referring to gases right now. We know from physics that kinetic energy is equal to 1/2 mv squared. And so what it means is that if we have a very heavy mass, if this is a large number, then velocity is going to be a small number. And if mass is very, very small, then velocity will be a much larger number to help compensate it. So the ratio of the relative rates of diffusion is equal to the square root of the inverse ratio of their molar masses. Gosh, that sounds awfully confusing. But what it's saying is that the ratio of their relative rates, so rate 1 over rate 2, is equal to the inverse ratio, which means the square root of the Graham formula weight of substance 1 over the square root of the Graham formula weight of substance 2. And that's the equation we use to solve problems. But this idea that small mass diffuses faster than molecules of a large mass is the key idea behind this. So the questions look like this. It says find the relative rates of diffusion for the gases krypton and bromine. So I want to know krypton compared to bromine. And that's going to be equal to the square root of the mass of bromine over the square root of the mass of krypton. So bromine is 79.9, but there's two of them, so it's 159.8 over the square root of krypton, which is 84.79. If I take the square root of each of these numbers, I end up with 12.64 over 9.208, and then when I actually divide them, it's 1.37. So that tells us that krypton diffuses 1.37 times faster than bromine. It's the lighter molecule, so it's going to diffuse faster. If we want to look at hydrogen and nitrogen, H2 and N2 is equal to the square root of N2 over the square root of H2, which is N2 is 14, so 2 of them is 28. H is 1, so that's 2. It ends up as 5.292 over 1.414, which gives us 3.74, which means that hydrogen diffuses 3.74 times faster than nitrogen. It's the smaller molecule, so it'll diffuse much faster.